Seems to be, like I said, it seems to be very slow today. So, and let me know if you see my slides. Okay, and like I said, once again, you are completely, I can't see anything except the one screen. So you'll have to let me know if there's any, excuse me, if there's any questions. Well, again, welcome back, everyone. We were talking last time about things like we're still looking at the industry as a whole, and we were talking about things like mobile virtual network operators and mobile virtual network enablers. And we ended up, I think, let me see if I can find. We were talking, let me go a little before this. We were talking about industry participants. One of the industry participants we mentioned was what's called the IP exchange. And this is where data between a visited network and a home network travels through this type of industry or this type of company. It's called the IP exchange, and it's just meant for it's a group that supports 2G, 3G roaming. These are the different generations. It supports things like these IoT, Internet of Thing devices. So think of it as a data, like a data pipe or a data tunnel between networks. And we'll talk more about that when we look at how data actually gets transferred between these networks. We also talked about another thing that networks need to do to connect to each other is signaling. Signaling is needed for things like, let's say you roam somewhere, the visited network has to tell the home network that you are there, and the home network then has to tell the visited network things about like your subscription information, whether you have any restrictions or whether you're allowed to do certain services. So a copy of your subscription information is then given from the home system to the visited system. Well, all of this requires signaling. Other things that require signaling would be delivering short messages. If you tap out a short message for a friend, that has to be delivered back to your home network. Authentication. The visited system needs to authenticate your mobile to make sure you really are who it thinks you are. So these are signaling companies or signaling aggregators. Companies like TNS, Transaction Network Services, companies like StarHome, Cineverse is a large one. Other ones would be iBasis. MTN does some signaling hubbing. So again, these are fairly large telecom providers. The other thing is delivering voice. When you communicate between networks, in the older days, it used to be just large networks would communicate with each other for voice services. So if someone in this network on the left, if they called someone over here at, let's say, British Telecom would charge AT&T to terminate. You always charge at the terminating end, at the end that you called. But likewise, if someone over here talked to someone over here, AT&T would charge them for terminating that call. So at the end of the month, then it was just what was called like a settlement of accounts. Your customers terminated this many minutes, my customers terminated this many minutes, so you owe me this much money. So it was very clean, it was very straightforward. There weren't a lot of other industries or other players in the middle here. Today, it's much different. Today, it's a wholesale market. Companies out here will buy bulk minutes from other providers. Most of the voice services today is data. Your voice is converted from an analog voice, like me speaking now, into digital signals. So these companies will buy like bulk usage or bulk minutes of use out here in here, and then they will resell it to companies here. So these companies then will terminate here, and they'll each of these participants here will get a little piece of the action. So if they charge a user here, let's say $1 to call over to here, this company here will probably keep 80 cents and pass 80 cents, keep 80 cents and pass 20 cents to here. This company will keep 5 cents and pass 15 cents. This company will keep maybe, let's say, 5 cents and pass 10 cents, and so on. It's shared among all these users because these are all different participants today. And that's what's known as the wholesale voice industry. Your voice is no longer just one point to another point. It goes through a lot of other providers to get from one point to the next point. Yes. You mean how do they solve the delay here? Well, with voice, yeah, voice doesn't really care that much about delay. I mean, you might notice a little bit, but voice doesn't care about delay. But data is a little more sensitive, but data doesn't follow this path. Data follows this path right here. Data is more like think of data like a big pipe going from the visited network where you might be over to your home network. So data travels through that tunnel, like a VPN, a virtual private network, some type of data tunnel. Voice comes in through these different providers, and there is some delay, but with voice over IP, that's the way your voice is today. Your voice is carried as data today. It's separated from the normal data, but there's not a lot of delay. Good, good. There's other industry vendors, and we don't go into all of these. There's industry vendors that provide network equipment. Huawei, Qualcomm, Nokia. We could name a lot of providers that provide just equipment to make the switching equipment, all this equipment, the radio equipment, all these things to make it work. There's also companies that do what's known as network monitoring. They look at the data, they look at the signaling, they look at all the packets that are going back and forth, just to monitor to keep the network going. And there's companies like Telecom, Squire. There's also IT providers, as you know, Cisco, HP, Dell, and there's other ones out there. And then there's companies that provide security, companies that provide roaming services, value added services, companies like Cellusys, companies like Zariat. So these are just some of the industry vendors. So when you look at the industry as a whole, there's industry vendors, there's providers of signaling services, there's providers of short message services. It's a huge industry. And this first part of this lesson, we just wanted to introduce you to just some of the key players in there. So that this is the end now of the first section. Now we're going to look at a different topic. We're going to look at a different topic altogether, a very important topic. When it comes to mobile telephony, it's important to understand identities. What is an identity? Well, if you look at a wire line, a wired telephone, you're really only known by this. If someone wants to call you, they just call your telephone number. You're stuck in that one position. Now, you might have a cordless phone, but you can't move about. You're pretty much tethered to that one spot. In mobile telephony, you have to have many different identities. You have to have a telephone number so people can call you. You have temporary numbers to set up your telephone calls, temporary numbers to use when you talk over the air. And we'll explain that. There's identities for the actual equipment itself. So each one of these pieces of equipment need to identify itself like a hardware identity. You have international identifiers, and that's necessary because if you roam somewhere, your telephone number does not point to your home network. You need to point to your home network by these international identifiers. There's different local identifiers. There's different routing identifiers. There's identifiers for the cell that you're in. So the point is there's a lot of different types of telephone numbers out there. And we'll take a look at some of these. We're not going to look at things like cell identifiers, but we want to see how is the mobile identified and in what ways is it identified. Now, there's a specification. We're not going to do this now, but there's a specification that identifies all the numbers. And that's by this group here, 3GPP, Third Generation Partnership Project. And we'll talk more about this as we go on, but 3GPP is like it's the standards group. They think of it like the group that writes the standards. They write standards for the radio. They write standards for the signaling within the network. They write standards for coders and decoders. They write standards for security. So anything that has to do with a mobile network, the Third Generation Partnership Project does it. So this is their website, 3GPP, and I just listed the steps you would take if you were to download this particular document right here. We're not going to do that now, but just be aware that that there is this organization out there, 3GPP. We did mention it in the previous lesson. We go back to the standards where it shows the ITU, it shows ETSI and ANSI, and it showed 3GPP. And again, these are just the steps you would take, and then the version, and then finally you just download it onto your computer as either a Word file maybe, or as a PDF copy, or maybe even as a zip file. Now, in mobile telecom, when you look at the mobile itself, the actual phone, the mobile phone itself, there's really three types of numbers. One of the numbers is what's called an E.164. An E.164 is a number that is in telephone number format. So telephone number format are the numbers that you use to call your family, call friends. In the world, all dialable telephone numbers follow this format. Now, there's some places where it's longer. Some places are very simple dialing. Some places are very complex. India is one of those countries that's very complex to dial. It depends on where you are. You have to dial maybe some leading digits, but most countries, when you dial a telephone number, your telephone number is made up of a country code. So there's a country code, and this is Ireland. For example, the country code in Ireland is 353. The next digits would be called the national destination code. And that could be 2 digits or 3 digits. So the national destination code normally points to which one of these telephone companies you're in. So if you're at Leica Mobile or Meteor Mobile or Vodafone, Earcell, you'll have a different national destination code. And I didn't list those, but you'll always be country code 353. And then your next digits, 2 or 3 digits, will be this. Lastly, you have a maximum of 10 more digits, and that's called your subscriber number, your SN. So this makes up your telephone number anywhere in the world. There's a maximum digits of 15. No telephone number is going to be more than 15, but they're always made up of a country code, some kind of national destination code, and then the rest of it is called a subscriber number. Now, in mobile telephony, that's your telephone number. That's your telephone number. It has a strange name, but your telephone number in mobile telephony is this name right here, MSISDN, mobile station ISDN. Um, yeah, it's kind of a strange name. There's a little history behind it, but it's just think of MSISDN as just your telephone number. That's what people use to text you. That's what people use to send you a short message. That's what people use to call you. It's what people use for WhatsApp. It's all that. That's your MSISDN. In mobile telephony, they also assign different network entities. Things within the network are also given a telephone number, and that's for routing purposes. We'll look at that later when we look at the protocol. But just think of all the different things within the network you might need. All of these, maybe there's databases, there's registers, there's mobile switches, and all of these are assigned a telephone number. So it's a number in telephone number format. And I just listed some of these right here. There's another type of number that's more of a secret number, and that's called your IMSI, your International Mobile Subscriber Identity. Now, your International Mobile Subscriber Identity is also 15 digits, but it's made up of the mobile country code and the mobile network code and the mobile station identification number. Now, that's also 15 digits. So again, if we go back to Ireland, Ireland has a country code of 353. That's what you use if you wanted to call someone or send a text message to someone who has an Irish telephone number. You would have to start with plus 353. However, this secret number that you don't know about or that you can't get has a mobile country code, and Ireland has a mobile country code of 272. So for example, Access Mobile Telecom, if I want to call someone that has that network, I would do plus 353 and then whatever their national destination number is, and then whatever their subscriber number is. However, there's a secret number that is communicated between these networks, and that's your International Mobile Subscriber ID, your IMSI, and that's mobile country code is 272. So this is used to uniquely identify you as a mobile subscriber. Now, that identity, this identity called your IMSI, it's really in two different places. It's in your, it's here on your mobile. It's in your SIM card. You can't access it. You're not supposed to be able to access it, but it's also in your home system. When you power your mobile phone on, your identity comes out over the air interface. That is not your telephone number. That identity is your IMSI. Your International Mobile Subscriber Identity identifies you uniquely in the world. And the mobile network uses that identity, that IMSI, to go find you and to find your home network. That IMSI points to who your home network is. Telephone numbers here can move from different providers. So someone with a telephone number right here, and it's called number portability. You can port out your telephone number to here. So your telephone number, the number you call to send a text message, the number you call that you use to call someone, that doesn't really identify you. The IMSI does. The International Mobile Subscriber Identity does. Now there's another one, and we're going to skip this one over. This is a routing number. It probably won't make sense today, but it's a combination of an E164 and an E212. If you combine those, if you take the mobile country code and turn that into the country code, and you take the mobile network code and turn that into this, you take that E164 part, you take this IMSI part, and then you take these rest of these digits and keep them the same, that becomes this new number. It's kind of a combination of the two. Probably does not make sense now. It's a number that's going to be used just for routing. It's going to route through the network based on this. Okay, that'll again, it'll make more sense maybe after a little later when we look at the protocol. So really right now, there's two numbers that you have to kind of understand, and they have numbers E. E.164 is a number that's in telephone number format, and E.212 is a number that's in IMSI, International Mobile Subscriber Identity format. Well, it'll be a little clearer, hopefully, when you use these things. So let's take a look at your telephone number, your MS-ISDN number. We know that your mobile station ISDN is made up of a country code, a national destination code, and a subscriber number. That's 15 digits long. That's right here. That's the number that anyone in the world is going to use to call you. So if someone over here on let's say this network picks up the phone and calls someone over here, they dial that telephone number. The telephone switching equipment will set up these voice paths. They'll set up a voice path to here or to here, and it'll route that call through these voice paths. It'll route the call to here, and then ultimately your phone is going to ring. Now, it's in mobile telephony, it has to find you first. If this customer over here on the right calls someone, let's say right here, you can dial that telephone number. It's an E.164 number. So you dial that number, it sets up a voice path to here, and it sets up a voice path to here, and the phone rings. Now, this network doesn't have to find that subscriber because in the wireline network, you're at that location. Your phone is wired to that location, but not so in mobility. In mobility, this customer could be somewhere else in the world. I could call Raphael and he might be in Dublin. Well, if this customer here picks up their phone and they call Raphael, and Raphael's telephone number is in Ghana, the switching equipment is going to send that call to Ghana. Ghana then has to go find Raphael. They say, where is he at? So the network now has to go find him. They say, oh, he's not in Ghana. He's up in Dublin. He's in Ireland. He's visiting Ireland somewhere. So this switch will then reroute that call all the way up to Ireland, and his phone will ring. So in mobile telephony, there's a lot that goes on. But for people to call you, they're going to call your E.164 number. So like we said, there's elements. Now we haven't talked about these elements yet, but if we take a look at let's say a mobile network, we have a piece of mobile phone out here. You got some kind of radio tower, radio cell site, and then you've got these strange names, SGSN, MSC, VLI. These are just devices that are in the mobile network. We'll talk about them. They're devices in the mobile network that just are used for mobile telephony. So all of these elements, all of these nodes, all of these devices in a mobile network are assigned like a phony E.164 number. It's not a dialable number. You can't pick up the phone and call this device. You can't talk to this device, but it's assigned a number that's in telephone number format. Think of it like a non-working number. That's what they're assigned. And again, that's going to be used for routing purposes. It needs to do that so it can route these calls. How is your IMSI used? How is your International Mobile Subscriber Identity used? Well, like we said, it's stored here. It's stored on your SIM card, and it's stored in this device called the Home Location Register. This is the central database in your home network that knows all your services, and it knows where you are. It doesn't know the exact cell. Let's say Raphael is roaming in Ireland. It doesn't know as he wanders around Dublin, it doesn't know each cell that he moves in, but it does know that he is registered with a switch in Dublin, Ireland. It knows the identity of that switch. So your home location register knows where you are, and your home location register also knows all of your services. So here's the steps that are followed when you, Raphael, let's say now gets on a plane and he flies from Ghana and he's going to go to Dublin, Ireland, and he's going to do some visiting there. So he arrives in Dublin and he powers his mobile phone on. Once he powers his mobile phone on, his identity that he doesn't know about, not his MSISDN, but his IMSI, which is his mobile country code, mobile network code, and then mobile station ID. That goes out over the air and is picked up by a cell tower. And the cell tower sends that to the switch. There's a communication between the cell tower and this mobile switching center. And it says, hey, here's a new user. And here is the international mobile subscriber identity. This mobile switch says, let me check and see if I know who this is. So it checks its own visitor register. Now, the visitor register is the device that's keeping track of everyone that's in that switch. So it goes to this visitor register, and the visitor register says, what? I don't know who this is. I've never seen this before. However, I do know that the IMSI is made up of this. The IMSI is made up of the mobile country code. And that IMSI mobile country code points to Ghana, and it points to a particular network in Ghana. Maybe it's MTN or whatever network is in Ghana, but the visit system now knows that the visit system now knows Raphael's home network based on this number right here. So it says, okay, I need to find something out about Raphael. I don't know anything about him. So it sends a signaling message through the signaling network. So the visitor location register in Ireland will send a signaling message to the home location register in Ghana. It says, hey, I have one of your subscribers here. Is this a legitimate subscriber, yes or no? And if it is, tell me something about Raphael. Tell me something about the services that he subscribes to so he can use those services in Ireland. So this thing does. It says, oh yeah, Raphael, a good customer of ours, and he pays his bill, and we like him here in Ghana, so I'm going to send you a copy of his profile, of his subscription profile. So it says, thank you for updating me. Here's his profile. And it comes to the visitor location register. Now the home system says, okay, I'm going to make a mental note. If anyone wants to get a hold of Raphael, any network element that needs to talk to Raphael or find out where he's at, will always go here first. Where is he at? Because this thing knows, oh, he's in Dublin now. Now, the system in Dublin also has a copy of the profile. And that's in a very high level look. That's how networks communicate with each other. Now, here it's showing a mobile switch and a visitor register and a home register. Devices, no, they changed the names of the devices, changed, but it's still the same concept. Yeah, Raphael. Yes.
Thank you very much. Steve, I wanted to find out,
Yes.
so the data from the home record, right, gets sent to the home location record gets to the visitor location record. And recently I've come to chance on something called data privacy, where when your data is sent over to maybe a third party, after a certain time, you have the right to tell this third party to delete it after they've used it for whatever reason they collected it for. So in this instance, what is the process around data privacy?
At this point, that's a very good question. That's a very good question. The question is data privacy. Um, the privacy part here is that the network between here and here is a closed network. Now, can other groups see that? In other words, it's a long data circuit that goes from here to here. Can someone else like peek into that information as it goes from server to server to server to server? Because it's going to hop between Ireland and Ghana. It's not a direct communication. So the question I think I understand is, how do you protect that data? Because this is a identity that someone would like to have, because then if I get a hold of the MC, I can pretend to be Raphael. The way these are protected are things like firewalls. So a firewall would be right here. Let's say in Ghana, MTN puts a firewall, and that's one of the products that Cellusys sells, is these firewalls. And the firewall says, I'm getting a message in from Dublin into my network. Is that really Raphael? How did where's the last time he registered? Well, maybe 5 minutes ago he was in Ghana, and now 5 minutes later he's in Dublin. That's not possible. So there's firewalls that protect the messaging coming in here, and that's part of the security part of it, and that's a very key thing. Now, at this point though, there's no data. Data is not in here other than the signaling data. But Raphael at this point cannot use his mobile phone to do www.anything.com. He hasn't got to that point yet. This is just registering him on the network. But that's a very good point. How do you protect this data? This network would protect the data. This network would protect data also. Because this is a signaling message here, this is a signaling message here. This network right here would have a firewall right here, and they say, hey, we're getting a message in here. Well, that message is a profile. Is that an inbound roamer into my network? Yes or no? Is that coming from a legitimate company here? Yes or no? Those are very important questions. How do you protect that data? That data is done with firewalls. I know we're kind of running to the time, but I'd like to do one more slide. One more slide. Okay, this is Raphael is in here. His home system has sent this here. The home system now does something else. The home system does this. It says that this visitor register tells the switch, tell Raphael to quit using his MC, because someone might be able to hear that MC over here. This is this MC, this international mobile subscriber identity, is kind of a secret. You don't want to know that. You don't want anyone else to know that, because if hackers or fraudsters, if they get a hold of that number, they can then pretend to be Raphael, and they can use his services. So what the network does is it says, tell the mobile network, tell Raphael his mobile phone to quit using his MC on the air interface. Instead, we're going to send this temporary number. It'd be like, okay, once Raphael says, I'm Raphael, the network says, okay, we know who you are now, but just over the air, use Richard. Richard is your new name now. So if anyone's listening, Richard, they don't know who you really are, and you're really Raphael. That's called your TIMC. So you have an IMSI, International Mobile Subscription Identity, or subscriber identity. And now you have a temporary mobile subscriber identity. And as long as Raphael stays there in this system, that this mobile switch knows him by Richard, not by Raphael. Okay, I think this is a good point to stop off. Next, we'll go into equipment identities. Questions on this?
Yeah, good evening, Steve. I would like to ask a question on the telephone numbers. From what we learned from the E.164, that is where we have the country code, and then we have the subscriber code, and then we have the numbers on itself. Now, I know that in the US, unlike in Ghana, people are still using the analog system where we still have the landlines, that is maybe your home telephone lines. In Ghana, we used to have landlines where we have the home telephone lines, which are gradually fading off. Unlike that one, we don't have a subscriber number. That is right from the country code, then the your subscriber number or the telephone number assigned to you. So therefore, that one, the digits are limited to maybe only 10. Whereas if we are using the mobile telephony now, we are up to about 15 digits. How does the system is able to switch to recognize either the system is the analog type or is the digital type? Do you have a system that does that conversion?
Well, if you call someone in your local, if you call someone on a mobile phone within your home network, you just dial the normal amount of digits. I mean, it depends on the dialing plan. You only dial someone's country code if you're calling outside the country. If I'm inside a country, I don't know that I'm dialing a mobile phone. In the United States, if you pick up the phone, you dial an area code, um, uh, off code, and then a line code. If I dial a telephone number in the United States, I don't know whether I'm calling a mobile phone or a wireline phone. There's no distinction. Some countries have a different dialing number, leading digits that identify a mobile network. In the United States and in Canada, your mobile telephone number is the exact same as a wireline number. So there's no difference that you would know. The only time I know I'm dialing a different number is if I need to dial someone else's country code. But when you're roaming, if I call a friend of mine and that friend of mine is roaming in Ghana, I don't know that. I just dial his telephone number. His network has to go find him in Ghana. Does that kind of make sense? Okay. If not, maybe I wasn't understanding it correctly, but that's the the dialing plans are going to vary from country to country. But your
Yeah.
MSISDN is a telephone number the network needs to route a call to you.
Yes,
Whereas your IMSI, yeah,
yes, I am of the opinion that, like in Ghana, we have the national code itself, and then we have the regional code. Like I don't know that of the US, where we have maybe the national code, the telephone code, and then maybe the state's code, so that if somebody is in Chicago or somebody is in Maryland, the code vary from each other. Or is it the same number
yes,
that is used, or they are not separated by a code? Unlike in Ghana, in those days they were separated. If you are in Accra,
okay,
different from if you are in Kumasi. If you are in Kumasi, it's different from if you are in Tamale. That means you call the country code first before the regional code, before the person's real number. That's why I wanted to
okay,
understand.
yeah. In the United States we always dial the area code. Like if I'm in Chicago, I'm at home near Chicago, I'm in my home network, and I want to call someone in Maryland. I just dial that Maryland number. Now that might be a mobile phone, that is be a landline. The dial plans, the dialing digits are the exact same, whether it's mobile or fixed wireline.
Okay, okay, I understand now. Thank you.
Good. Others. Okay. Well, in that case, on Wednesday, next Wednesday, we'll start with a couple other telephone numbers.